Hello, class, and welcome. Today, we're going to roll up our sleeves and tackle a really foundational skill in systems analysis: how to build a clear, correct, and useful level 0 data flow diagram. So let's get right into it. Does this feel familiar to anyone? You're staring at a dense page, maybe several pages, of project requirements, and you're just trying to figure out how to turn all that text into some kind of clear visual plan. It can feel really overwhelming, right? But the good news is, there's a powerful tool designed for exactly this challenge: the data flow diagram, or as we call it, the DFD. So why do we even do this? Why model data flow? Well, think of yourself as a detective. You're trying to uncover the hidden logic of a business process, and the DFD is basically your map. Specifically, we're focused on building a level 0 DFD, which is the highest level, big picture view of the whole system. It shows us what the system does long before we start worrying about how it's going to do it. At its heart, a data flow diagram is all about showing us data in motion. It's one of the most common ways we model business processes. And as a systems analyst, this diagram becomes your absolute best friend. It's the tool you'll use to explain your understanding of a system to everyone, from the end users to the developers, making sure you are all on the same page and speaking the same language. Okay, so before we can even think about drawing anything, we need to gather our building blocks. This is probably the most important step. You have to carefully read through your requirements document and start identifying the key components of the system. We're basically going on a scavenger hunt for 4 very specific things. And here they are. These are the only 4 pieces you need. Every single DFD, I don't care how simple or how complex, is built from just these 4 symbols. You've got external entities, processes, data stores, and of course the data flows that connect everything together. Let's break down how to find each one in your requirements text. First up, external entities. These are the people, the departments, or even other systems that exist completely outside of your system, but they interact with it somehow. The trick is to look for the nouns in your requirements. Are they talking about students, a billing department, another computer system? If it sends data to your system or receives data from it, well, you've just found an external entity. Next, we hunt for the doing words. Processes are all about the verbs. They represent the actions that the system itself performs to transform some incoming data into some outgoing data. So when you read a phrase like, "the system will generate a report," or "staff will maintain course information," that's your signal. Ding, 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 you found a process. These will become the core functions in your diagram. So what happens to data when it's not moving? We call that data at rest, and that's where our data stores come into play. You need to look for collections of information, files that the system needs to save or look up. So if you see phrases like the course offerings file or the buyer database, you've hit the jackpot. You've found a data store. It's just a holding place for information. All right, so you've done your homework, you've read the requirements, and you've identified your components. Now it's time to actually build the map. And we're going to follow a very structured, step-by-step approach to make sure our diagram is logical, clean, and easy for anyone to read. Let's start with step 1. Take those external entities you just identified and place them around the edges of your page. Here's a pro tip. I like to put the main sources of data on the left side and the main places data goes on the right. Doing this right way helps establish the scope and the boundaries of your system. It tells you where your world begins and ends. Now, for step 2, you're going to take your major processes and place them right in the center of the diagram. These are those core functions we talked about, those doing words you found. Very often, each major use case you've identified is going to correspond to one process on your level 0 DFD. Make sure you give each one a number and a clear, action-oriented name. Step 3, time to place your data stores. A good rule of thumb is to position them pretty close to the processes that actually use them. So if process 1 is the one that writes information into a specific file, it just makes sense to place that data store right near process 1. This helps keep the diagram from becoming a tangled mess and makes the relationships obvious. And finally, the step that brings it all to life. Step 4, we connect everything with data flows. These are the arrows that show data in motion. You'll draw arrows from entities to processes, from processes back to entities, and between your processes and your data stores. And this part is absolutely critical. Every single arrow must have a label that describes what data is flowing. An unlabeled arrow is useless. It tells us nothing. Okay, so now we know how to build the diagram. let's talk for a minute about how to build it correctly. There are a few fundamental syntax rules. You can think of them like the grammar of DFDs that are super easy to get wrong. So let's look at a couple of the most common mistakes I see.
So here's a classic one. Imagine a user wants to add their information directly into a database. In your diagram, is it okay to draw an arrow from the user entity straight to the user file data store? What do you think?
Absolutely not. No way. This is what we call an illegal data flow. And here's the crucial point to remember. An entity can't just change data on its own. It needs a process to act as the go-between. So the user sends their information to a process, maybe it's called update profile, and that process is the one that does the work of writing the info into the data store.
All right, how about this one? Let's say you need to move some information from, I don't know, an enrollment file over to a course history file. Can you just draw an arrow connecting those two data stores? Nope, that's another big no-no. It's also an illegal flow. You have to remember that data stores are passive. They're like filing cabinets. They can't do anything on their own. You need a process, maybe one called archive enrollment data, to do the work of reading from the first data store and writing to the second one. The key takeaway here is a process must be involved in every single data transformation. So, before you call your diagram done and get ready to submit it, it is absolutely essential to do a final review. Running through a quick checklist can help you catch those little logical errors and make sure your diagram is syntactically perfect. Use this checklist seriously. First, check your processes. Does every single process have at least one input arrow and one output arrow? A process with only inputs is a black hole. Data goes in and never comes out. One with only outputs is a miracle. Data just appears from nowhere. Next, look at your data stores. Does each one have at least one arrow going in and one coming out? Otherwise, why is it there? Third, check your labels. Did you label every single arrow with a descriptive noun? And finally, review the connection rules. Remember, you can only connect different types of symbols. No entity-to-store connections, no store-to-store connections.
And I really want to leave you with this important thought. This explainer and the assignment it's based on, it's all designed to help you master the method. The goal is not for you to perfectly copy some final diagram. The goal is for you to learn the thinking process behind translating messy requirements into a clean, logical model.
And please remember, this is not just some academic exercise we're doing. A well-constructed DFD brings incredible clarity to complex business problems. And it saves real-world projects real time and money. It's an incredibly powerful tool for analysis and for communication. So the question I'll leave you with is this. Now that you know how to create the map, what business problem will you go out and solve first?